Alright, so section 12.5 is on the law of cosines. 12.4 we talked about the law of sines, and that's used for certain types of triangles, in particular what are called angle-angle-side or angle-side-angle triangles. The law of cosines is used for these two triangles that you see right here, side-angle-side and side-side-side. And you don't have to memorize that. I'll show you kind of in a sec what's an easy way to tell when you're supposed to use the law of cosines, when you're supposed to use the law of sines, because it's not really all that hard to tell, and you will see that in just a sec. Before we do that though, I want to look at this problem. This is a proof for the law of cosines. We're going to prove where this comes from. Okay, the law of cosines is basically kind of like a fancy version of the Pythagorean theorem. So let's take a look at this triangle and it'll give us a couple hints how to do it. It says use the Pythagorean theorem for this triangle, which I'm going to outline in red right here. Okay, so use the Pythagorean theorem. Well, the Pythagorean theorem says a squared plus b squared equals c squared, or the leg squared, which is that, plus the other leg squared, which is that, is equal to the hypotenuse squared, which is this a. And they happen to use a for the hypotenuse. Normally it's used for the leg, but it doesn't really matter. Okay, let's simplify this now. So h squared plus, if we FOIL this out right here, we would get b squared minus bx minus another bx, so that's the same thing as minus 2bx, and then that last thing is going to be plus x squared, and that's equal to a squared. So let's kind of box that off for a sec. We'll keep that in mind. Okay, then let's use the Pythagorean theorem on this this blue triangle right here, and this one's a little bit easier. You have x squared plus h squared equals c squared. So x squared plus h squared equals c squared. So that's the Pythagorean triangle for this one right here. And then let's also keep in mind something, because this is called the law of cosine. So let's take the cosine of this angle. And cosine is adjacent over hypotenuse. So adjacent x over hypotenuse c. So the cosine of angle A equals adjacent over hypotenuse. Okay, and actually they told us that right here. Okay, so how does that help us? Well, notice that in both the red and the blue equation we have x's. So let's take that green one that we have and let's solve it for x. Let's multiply this side by c, multiply this side by c. So that means x is equal to the cosine of a. Okay, that's what x equals right there. And then we also want to notice something else. We want to notice that, I'm going to run out of colors in a sec. We want to notice that x squared plus h squared is equal to c squared. So if I look over at this equation, there's an x squared, there's an h squared, and we said that if we add these together we get c squared. So I'm going to rewrite this. I'm going to rewrite it as this b squared is still here, minus 2bx is going to be minus 2b. Well, notice x is something we solve for right here. X is equal to the cosine of a. Okay, and then what else do we need? Then we need this x squared plus h squared, that's equal to c squared. Oops, I don't know why I'm writing the squared over there. That equals c squared. And then finally we have this a squared right here. Okay, we have this a squared. So what we just wrote is actually equal to, it's basically equal to the law of cosines. Okay, that problem right there, that thing that you see, that's kind of a modified version of the law of cosines, basically. And actually, there's one mistake here that this is supposed to be a c cosine a, because we had this. So this should actually be 2bc cosine a. So let's just fix that. This right here is the law of cosines. It basically is like a modified version of the Pythagorean theorem. And we'll see where this comes from in just a sec, but you may notice the Pythagorean theorem part is usually this. It's usually hypotenuse squared equals leg squared plus leg squared. This part right here is the only extra thing, and that comes from triangles which are not right triangles. So that's the best way to describe it. The law of cosines is the Pythagorean theorem, but it's the Pythagorean theorem for triangles that are not right triangles, like the one that you see right there. Even though these are right angles here, this big triangle right here is not a right triangle. And so we can use the law of cosines for that. Okay, here's kind of three different versions of it. You can see the one that I tend to remember is this one right here, because that one looks most like the Pythagorean theorem. C squared equals a squared plus b squared. And then here's how to remember. Whatever this side is, that's c, that's the one that you're taking the cosine of. So this side is b, we're taking the cosine of b. This side is a, we're taking a cosine of a. The other thing to remember is that if it's a squared plus b squared, over here you're multiplying 2ab. If it's a squared plus c squared, you're doing 2ac. If it's b squared plus c squared, 2bc. So you're using those letters to square, and you're using them to multiply by 2 also. Okay, so that looks confusing. I think it'll be clear when we do an example. And I told you I would tell you how to tell when to use the law of sines, when to use the law of cosines. Here's the easiest way to do it. Instead of trying to memorize something, always try to use the law of sines if you can. And if you can't, that's an indicator that you should use the law of cosines. So I'm going to try to do that right now. The law of sines, I'm going to start by using that, because that's a little bit, I mean, neither of them are too hard, but the law of sines is slightly easier to use. Okay, here's the law of sines. So let's try that. So angle B is 36. So I'm going to do sine of 36 degrees over its side, which they don't give us. And then what do they give us? Well, they give us both side A and side C. It doesn't matter which one we use. Let's just use C. They don't give us angle C. So sine of C over its side over 5. Now here's the problem. Here's why you can't use the law of sines. If you cross multiply these, notice that we have two variables here. We have a variable right here, we have a variable right here, and you cannot solve an equation. If you just have one equation, there's two variables in it, you can't solve it. It's impossible to do. Okay, so that's how you can tell that the law of sines is not going to work. If we set up the law of sines and we end up with two variables, that's an indicator we can't do it. Okay, so that means we need to use the law of cosines. Okay, here's the law of cosines. The law of cosines, it has three versions. And since they gave us side B, I'm going to use the B version. So it's b squared equals, we know if we're dealing with side B, that means we're going to be taking the cosine of B. And then it's going to be the other two sides squared. So a squared plus c squared minus 2 times a times c. Those letters are used twice right here. Okay, so that's the setup. Now all we need to do is just plug in whatever we're looking for. So, by the way, we said that this works for side angle side triangles. So there's a side, there's an angle right there. I don't want to confuse you. That A doesn't mean like the letter A, it just means angle. And then there's a side right there. So this is a side angle side triangle. Okay, a squared, well, they tell us that side A is 7, so 7 squared. They tell us c squared, they tell us c is this side, so that's 5 squared. And then minus 2 times a, which is 7, times c, which is 5, times the cosine of b. And the cosine of b is equal to 36 degrees. Okay, so I'm just going to pull up the calculator here so we can use this. Okay, so the cosine of b is 36. Now all that we need to do is literally just plug all that stuff in and come up with an answer. And I just want to show you one thing that people tend to make mistakes on. 7 squared is 49 and 5 squared is 25. When you add those together you get 74. Minus 2 times 7 is 14. 14 times 5 is 70. Okay, so that is going to be 70 cosine 36. Here's the mistake that people will make. They'll say, well, okay, well 74 minus 70 is 4. So that's going to be 4 times the cos 36. That's wrong, because that's an order of operations mistake. These are being multiplied and those are being subtracted, and you have to multiply before you can subtract. So what we need to do now is just plug this in a calculator, 74 minus 70 cos 36, and that's going to equal b squared. Okay, so let's get out of here for a sec. We have 74 minus 70 cos 36. Make sure we're in degree mode. We are. So minus the cosine of 36, and then remember this equals b squared, so we need to square root that. So second answer, and b is then going to be 4.17. I think they want us to round usually to the nearest 10, so let's round that to 4.2. Okay, so this side equals 4.2. And it says solve. So to solve something, we need to fill in 3 sides and 3 angles. We now have 3 sides. And here's the thing: once you find one of the missing things, you can now use the law of sines. Remember, before we couldn't use the law of sines because we had 2 variables. We don't have 2 variables anymore. Now when we do it, we're only going to have 1. And I'll show you what that looks like. So let's do the sine of 36 over its side, and let's use the exact answer. The exact answer was like 4.67, etc. I'm going to show you how to use that in the calculator in just a sec. And then we can solve for either of these, so let's just do the sine of c over 5. And now it's a law of sines problem like what we did before. So that's going to be what we did in the last section, I should say. That's going to be 5 times sine 36. And from here, all we need to do is we're going to divide this by 4.167. Divide this by 4.167. And we have the sine of c equals that. So in order to cancel out sine, we need to do inverse sine. So inverse sine of this whole thing right here. Let's do that. And I want to show you how to use that 4.167, the exact answer. Okay, so we're doing second inverse sine. We have to be careful with the parentheses here. So second inverse sine, 5 sine 36. So 5 sine 36, close that parentheses, divided by, and then I don't want to use 4.2, I want to use this 4.16 here. So I'm going to do second answer, and the reason I'm doing that is because that's taking the answer from the last problem, which was this 4.16 number. It's dividing by that. Okay, so you get 44.84. I'll show you what it looks like if we had rounded. It's still going to be pretty close, but let's use 4.2 instead. So you see it's going to be a little bit off. Still pretty close, 44.4, but if you want a more accurate answer. So 44.8 degrees is going to be angle C. That's what we solve for. And then all we need to do to solve for A, well, we have 2 out of the 3 angles, so we just need to add those and subtract from 180 degrees. And when we do that, this right here, I believe, is 80.8, so this should be 99.2 degrees, if I did that math correctly. So now that triangle's solved. We found all 3 angles, all 3 sides. If they don't give you a picture, which they didn't here, what you can do is you can just draw the picture. So you can see I drew it right there, as long as you're fairly accurate, and then the setup is still the same. So you can see how that was plugged in, and again, just to note, down here, 52 minus 48, you can't do this. You can't. That's an order of operation. You have to multiply these first and then subtract. But the problem is otherwise solved the exact same way. You plug this into a calculator and then you square root it, because that will give you G. And this is what the answer turns out to be. G is 6.7, so we would plug this in, and now we could use the law of sines. Sine of that over 6.7 equals sine of, let's say, h over 4. And we could solve it. You could see what they come up with for the answers. Okay, now here's the one catch for law of cosines. You might remember from 12.4 that occasionally when we were using the law of sines, we wound up with having 2 different triangles. Okay, so we have to be careful with this when we're doing the law of cosines. If we don't want that to happen, okay, we always need to start by finding the measure of the largest angle. And as it says here, that's done to ensure that the other 2 angles are acute, because otherwise we could wind up with a confusion about getting 2 triangles. So I'll show you how that looks. It'll be clear when we do an example. Start with finding the cosine of the largest angle. So notice this is a side, side, side triangle because they're giving us 3 sides but no angles. And we want to deal with the largest side. The largest side is side A. So let's set that up. A squared, and remember, if we're taking that side, it's going to involve taking the cosine of this angle. And then the other 2 sides minus 2 times the other 2 sides. Okay, now what we need to do is plug things in, and if we have time, I think I'll show you what would happen if we had not used the largest side, because I think it might work for this example. So let's plug this in. So side A is 16, so 16 squared equals side B is 9. 9 squared plus side C is 10 squared minus 2 times 9 times 10. And obviously we don't know what angle A is. We know everything else though, so this shouldn't be too bad. So let's simplify this. So this is 16 squared is 256. This is 81 plus 100, which is 181. Minus 2 times 9 is 18, and 18 times 10 is 180. Again, we want to avoid the mistake of doing 181 minus 180. We cannot do that because this is being multiplied, and you have to multiply before subtracting. So instead, let's move this over by subtracting it. So 256 minus 181 is 75, and that's equaling negative 180. Then the negative is here, so it still has to be here. Let's divide by negative 180 from both sides, and we would get the cosine of A equals 75, or negative 75 over 180. You don't have to reduce that. If you did, it would reduce to 5/12, but that doesn't matter. Okay, now how do we solve for cosine? We solve for it by taking the inverse cosine, because that will cancel. And we'll take the inverse cosine of that, and it's only going to be there's only one possible angle. The sine, remember, from 0 to 180, sine is positive in 2 quadrants, but cosine is only positive in 1, so we're not going to run into that problem as long as we started with the largest angle. Okay, so let's do that, and we're going to get an answer of 114.6 degrees, so that is angle A. Let's fill that in. So 114.6 degrees. Now we can use the law of sines, which we were not able to do before. And you can test it. If you try to set up the law of sines originally, you'd end up with two variables, which we can't have. Now we can do this. So sine 114.6 over 16 equals, it doesn't matter which side we choose. Let's just choose the C side. So sine of C over 10. We will cross multiply. And you're going to get this right here, equals 10 sine 114.6 degrees. Divide both sides by 16, and then we will cancel out the sine by taking inverse sine. So sorry, this is a little bit messy, but the inverse sine, that's a 16 here, not a negative 16. So the inverse sine of 10 times the sine of that angle over 16. Let's find out what that is. Inverse sine of 10 times this, oops, that's not inverse sine. Inverse sine times 10 sine 114.6, so 10 sine, and I'm going to do second answer again because answer is going to give us that 114 that we had up there. And then we're supposed to divide by, I believe it was 16. It is 16. And this is going to give us angle C, which is 34.6 degrees because we were solving for C. So 34.6, now we can easily find the third one by adding these together. And then we should subtract that from 180 degrees. And I believe when you do that, these are going to be 149.2, which leaves 30.8 degrees as our final answer. And that triangle is now solved. We have all three sides, and we have. All right, so that's basically how we do it in the case of a side case. Again, the key was we want to start with the largest side, and that in this example, I don't think it would cause a problem, but in other examples it would. Okay, so this is just a little table. Like I said, I wouldn't recommend memorizing these. They do tell you if it's side, or if it's side, angle, side, use the law of cosines. If it's one of the other two, use the law of sines. I recommend starting by trying the law of sines, and if it doesn't work, that's how you know to use the law of cosines. All right, so let's use a kind of a word problem example here. I just want to see which one is better. Well, maybe we'll do both. So, scuba diver looks up 20 degrees and sees a turtle 9 feet away. Hopefully you can see that. The picture's a little bit blurry. She looks down 40 degrees and sees a blue parrotfish 12 feet away. How far apart are the turtle and the parrotfish? Which means we're looking for this distance right here, distance A. Okay, well notice this triangle, those two angles together, I'm just going to redraw this. That's a 60-degree angle. And you combine those. We're looking for this side right here, which obviously would be angle A. They tell us this is 12 feet, and they're calling that side B, and they're telling us this is 9 feet. Okay, so we need to use the law of cosines. This is a side angle side case. So let's try to fill this in. So we'll do side C is the angle, so we'll do C squared, and that means we're going to use the cosine of 60. And then A squared plus B squared. So there is A squared. Actually, you know what? They told us C. C is 9. So I'm just plugging in the 9. Nope. Sorry, that's a mistake. I shouldn't have written C there. I should have written A. So 60 is opposite to this. We're taking the cosine of 60, so this should be A squared. A squared equals the other two sides squared. So 12 squared plus 9 squared minus 2 times 9 times 12. Okay, let's simplify this. So, yeah, this one is actually easy because there's nothing to solve. You just have to add these together. So 144 plus 9 squared is 81, so that's 225. Minus 2 times 9 times 12 would be 216 cos 60. And this right here is going to be A squared, and then we need to square root it to find A. And that's all they want us to do. They actually don't want us to solve the rest of that triangle. So let's just take the square root of that big number right there. So square root of 225 minus 216 cosine of 60 degrees, and that's going to be 10.8. so that means the distance from the turtle to the parrotfish is 10.8. Sometimes they won't give you a picture, which they didn't right here, so this is a marathon example. Just want to show you how to set that up. So it says she ran 6 miles in one direction. Doesn't really matter which direction, but let's say this is our starting point right here at the blue. So she's running 6 miles this way. She turns 79 degrees. She goes 7 miles that way. How far was she apart? So that means you want to find the x value. You can see the setup right there, and then you plug that in a calculator, and it turns out to be about 8.3 miles is as your final answer. So that is the law of cosines. Hopefully it makes some sense.